What's x squared to the 1/3? 2/3. Is it like anything else that I could simplify? No. What's x to the 1/3 squared? Same thing. Exact same thing, because when you take a power to a power, you multiply. Since x to the 1/3 is the cubed root of x, we can write x to the 2/3 as this or this, because it's really the same. What we will find today is just more of the same exponent rules, but we're going to have more fractions involved. And we're not going to be intimidated by fractions. We have calculators to help us. And we may see things like this, but we actually know that all of these are the same. Like these are all x to the 2/3. This is x to the 2/3. This is x to the 2/3. This would be the same as that one. This is the same as that one in terms of how it's written. Now, if a 1/3, a cubed root is a 1/3 power, and I want to find 8 squared cube rooted, I actually can just write this as 8 to the 2/3. Okay? I can. Or I could square 8 then cube root it. I'm going to get 4. Now, there are ways to do this by hand, but you guys can just plug this into your calculator. Plug 8 to the 2/3 into your calculator. You guys get 4? Yeah. Okay, cool. Well, watch this. Cube root of 27 to the 4th. I would write this as 27 to the 4th to the 1/3. And actually, I can write that as 27 to the 4/3. I can type that in my calculator too. What is it, 81? You guys get 81? You know how I did that in my head? Ready? I changed this to 27 to the 1/3. The cube root of 27 is 3. And 3 to the 4th, 3, 9, 27, 81. That's how I got that. Did you have to do that? No. You have your calculator. But having fractional powers actually helps us. It's actually easier to type in a fractional power, in my opinion, than it is to type in all these 4th roots and cube roots. Like, I don't know where that is in the calculator anyways. Now, this is a 4th root. That's 81 to the 1/4, and that is being squared. What does that equal? What do I do if I have 1/4 as a power taken to another power squared? Multiply. What's 1/4 times 2? 1/2 or 2/4. What's 81 to the 1/2? 9. Square root of 81. Okay? You need to be able to write things as fractional powers like this. You need to be able to, in some situations, take a number and write it using the root notation. So if I have 125 to the 2/3, I would write this. Once my thing stops freezing. As either 125 squared to the 1/3 or 125 to the 1/3 squared. Does that make sense? How I can split that up into two things, kind of like the bottom ends up being like the root power, and the top ends up being a whole number power, a fractional power for the bottom. Well, that means I could write this as the cubed root of 125 squared, or the cubed root of 125 squared. They're both the same. Or you could type that into your calculator. 4 to the 5 halves. Let's just do this one. Does it make sense that 5 halves can be written as 5 times 1 half?
So basically not really simplifying it, we're just writing it a different way.
Just writing it a different way. And that's the same as that. And I actually could simplify this. The square root of 4 is 2, and 2 to the 5th, 2, 4, 8, 16, 32. Stay with me, Miss Pierce. Thank you. Put that pencil on that paper and try to learn what is going on. What's the most helpful for the ones we're about to do is not keeping things in this form. What's most helpful is to rewrite x to the 4th cubed root is as x to the 4th to the 1/3. Right? Just like we've done. This is x to the 4/3. I'm going to leave it like that, actually. I could write this as x to the 1 1/3. And I could write this as x times the cubed root of x if I wanted to. Sure, I can do that. But actually, right now, all I want you guys to be able to do is just say it's x to the 4/3. What would be the 4th root of x cubed? How could you rewrite that? X to the 3/4. X cubed to the 1/4. 3 times 1/4, 3/4. Okay, do the next two, please. A 5th root is just a 1/5 power. 2 times 1/5, 2/5. 5/3. You're probably thinking to yourself of a shortcut. What's the shortcut? Mr. Quinn, what is it?
Put the number in the square root.
The number in the square root?
Over the one on the outlet.
Right, ends up on the bottom. The number in ends up on the top. It's not always necessarily like that, because I can write things a little bit differently. Like I could write things like the cubed root of x to the 5th. It's just whatever's inside the square root, that's the fractional power, right? 1/3 to the 5th, 5/3. I mean, maybe don't come up with a rule, just maybe always write it as a power to a power using fractional powers. Fractional powers will always help you when you're manipulating things, okay? 5 times a third, 5/3. Okay, well, what if I give you this? X to the 2/5 times x to the 3/5. Well, it's a good question. Do I multiply them? Let me give you a different example, and you're going to tell me what the answer is. I always come back to this one, because it's the best one to use. Mr. Garcia, x squared times x cubed, what is it? To the 5th. And what did you do to 2 and 3 to get 5? You added them. Right. There's different ways to putting things together. You can multiply and put things together, but I add it. Okay? Well, if I'm multiplying, I should just add. That's the next question. What is 2/5 plus 3/5? 5/5, right? Fractions are like terms, you know? If you have like 3 x's plus 2 x's, you don't have 5x squareds, you have 5 x's, right? 3 apples plus 2 apples. I have 2/5. I add 3/5. How many fifths do I have? 5/5. So you don't add the denominators together. This ends up being x to the 1st, or x to the 5/5, which is x to the 1st. What happened here? What's x squared divided by x to the fifth? Where's that x to the third? Why? 2 of these x's cancel with 2 of these x's. We subtract the smaller number from the bigger number, and it ends up in the same spot. So, x squared, x to the fifth, was 1 over x cubed. What about x to the 2/3 divided into x to the 1/3? Take the bigger number, subtract the smaller number. Whatever we have left over ends up in that spot. What's 2/3 minus 1/3? 1/3. Where does that 1/3? In the bottom. What if I have 2 fractional powers, 1/2 and 2/3? Multiply. What's 1/2 times 2/3? Not sure? Use your calculator. One-third. This is just x to the 1/3. Don't be afraid about fractional powers because all the rules are still the same. What I'm going to tell you to do is if I ask you to simplify this, rewrite it so that you have fractions. This is x to the 7/3 times x to the 2/3. When you multiply, you add. If you are not comfortable adding 7/3 and 2/3 and getting 9/3, and 9/3 is 3, well then we could use our calculator. Square root of x cubed, I would write it as x cubed to the 1/2. This is x to the 3/2. The square root of x to the 5th, that's x to the 5th to the 1/2. I'd write that as x to the 5/2. Which one has the bigger amount, the top or the bottom? The bottom. 5/2 minus 3/2. 2/2, which is just 1. This ends up as 1 over x. This is how we're going to do these. You can't use your calculator. You can't cheat. We're going to have to convert to fractions and manipulate by adding, subtracting, multiplying, dividing. Look at this guy. The cubed root of x squared to the 6th. Oh gosh. You know what I would do? X squared to the 1/3 to the 6th. What do I do with these 3 numbers? Multiply. 2 times 6 divided by 3. This is x to the 4th. Okay? Nobody leaves this room until all 10 calculators, the yellow calculators, are replaced in the front. We've already done these. Cubed root of 27 is 3. X to the 12th to the 1/3. Not yet. Is x to the 4th. Y cubed to the 1/3 is y to the 1st. We got them?
Yeah.
All right, go. Is y to the 1st. Thank you. So in the future, this looks good. You're going to go to period 4, and you're going to slide it here, okay? Good. X to the 5/2 is x to the 2.5, x to the 2.5. Y cubed to the 1/2 is y cubed, is y to the 3/2, which is y to the 1.5. That's y to the 1st root y, y to the 1. and a half. Let's see. Let's finish off with a couple ones like these. Fractional powers. Well, power to a power. Take everything to that power. Now, 16 to the 3/4 I know is 8. Why? Because I'm going to write this as 16 to the 1/4 cubed. I know that the 4th root of 16 is actually 2, and then 2 cubed is 8. For you guys, though, if you ever have a number to a power and you're kind of confused by it, you're going to do 16 to the 1/4 power. Sorry, to the 3/4. 16 to the 3/4. 8. Okay, x squared to the 3/4. 2 times 3/4. I'm not sure what it is. 2 times 3/4. 1 1/2. It's 3/2. Maybe leave it as 1 1/2. Do you know how to do fractions? Yeah, you do. 3/2. Why did 8 to the 3/4? 8 times 3/4. 6. Okay. This is 8 x root x, y to the 6th. 1 1/2. So I got 8 to the 2/3 of x cubed to the 2/3 of y to the 6th to the 2/3. 8 to the 2/3 is 4. You can check 8 to the 2/3. That's the cubed root of 8 squared. 4. 3 times 2/3 is just 2. 6 times 2/3 is 4. There you go. Definitely skipping the last ones. And these previous ones, we'd be able to do divide by 3, cubed root of 64, divide by 3, cubed root of 27. All right, so fractional powers, we're just going to have to work a little bit more with fractions, but we can do it. That's the lesson.